Hello folks, how you all doing out there? Well, it's been a few days here and I've been puttering around with this thing, trying to increase the current. And let me show you what I did besides removing the pilot light, which I think I showed you already. Over here, you see I bridged a 150,000 ohm resistor with I think it was a 1 meg, 2 watter. The one that's in there, the old style, that's 2 watts also. Because it read 172,000 ohms. I had to disconnect it out of the circuit in order to do that. So I bridged, I think it's a 1 meg or 1.1, I don't recall now, over it. It's an exactly 150,000 ohms now. So that part is taken good care of. I'm trying to increase the current, and of course I had to go in on the computer and get on the Ohm's law calculator, and I put down some figures here from the calculator, and the test I'm making now is 120 volts. Yeah. Okay, here it is here. With a 10,000 ohm resistor, I had to dig through my resistor boxes and get a high wattage resistor. With 120 volts, it's supposed to be 12 mils. Okay? So that's what I got here. This is a 10,000 ohm resistor. I have 121 coming in. The meter's not going to read right when I tip it on the side if I turn it off. It won't go to 0 unless I put this down on the bench. It's funny that the milliamp meter is not affected, but this is out of balance somehow. I don't know. I had a little problem with it, and I had to take the face off and adjust the little slider to get it to 0. However, if you turn it on the side, it ends up this way anyways. So each time I put the slider back on and I line it up, it would freeze the needle. So I had to cut off the little plastic tab that's on the adjuster here. So now all is well. And this face comes right off. I can just pull it off. I had the meter completely out of the unit, but I don't have to do that this time around. All I got to do is just pull the face off and move the little adjuster, because this thing here binds in there. And the little plastic tab, so the little tit that's on the end of this plastic screw adjuster here, you couldn't get it in. It kept jamming this needle up. So that's all right. I can just pull the top off and adjust it. But once I get the unit back down on the bench, it goes right to 0. So that's not a problem. But anyways, we're gonna put 120 volts in. We got the Variac. I got it in some styrofoam here. Try to hold it up right here. I looked into trying to put the Variac here, but it won't fit. The chassis is not deep enough for it. So that's why the manufacturer put it on the side of the cabinet, which I really don't like, but that's just the way this was made. However, right now we've got 121 volts going in. And when we put a load on it, which we're going to do right now, it's drawing about 10 milliamperes. And it pulls it down to 107 volts. So what I would have to do is to crank this up should get this up on 120. It's very, very difficult here. Just touch it, it's very sensitive. Well, that's as close as I can get it. All right, and now she's drawing roughly about 13 milliamperes. And don't go by this because the meter's on the side. 13 milliamperes with this. It's lukewarm. With this resistor on, if I take the resistor off, watch the meter. So it's 138 volts. This cannot deliver the current. I thought maybe this was the problem, but no, it isn't. So you're not going to get much more current out of this. What you have to do is to crank up the voltage way higher when you put a load on it, like with a radio or whatever. In this case, it's the resistor. Now, there's more tests I can make with the 10,000 ohm resistor. And I just picked a bunch of random things, like 450 volts. And I wanted to draw 15 mils out of it. I didn't know what the resistance was. I looked it up on the internet, and it's 30,000 ohms. Okay. That's never going to happen. You're not going to get that kind of current out of this thing. And in a last-ditch effort, I figured, okay, I'm running low voltage. I'm running only 138 volts now, so I put a 450-volt, 47 microfarad electrolytic in parallel with this 700-volt 12 microfarad capacitor here in hopes that it might give me a little more current. That's not the case, because once it draws it off of this, that's it. So there's no way this thing is going to power anything more than a few milliamperes, and I, for the life of me, cannot figure out how to get more current on this. The transformer is big enough. It can put out 200 mils max. I should be able to draw 150 mils out of this power supply, putting out 450 volts, or even 75 milliamperes. So, putting that back on again, the voltage is, well, the current is up to 13 mils, and the voltage is down to 122. So it's fine as long as I push up the voltage. And this is what I have to do on the tube radios, the little battery sets. They need 67.5 volts. Okay, so you feed it with 68. But as soon as you connect it to the radio, it drops down to 53 volts. So you've got to crank it up well over 75 volts, 75, 76 volts, or even as high as 80, in order to get the voltage going into the radio to be 68 volts. And so we're really back to the ICO 950B situation here. I can't seem to get enough current out of this. I'm pretty much at my wit's end, but I'm still plugging along. I'm not giving up on it. There's got to be a way of increasing this current. Got to be. So we're going to make some more tests at a higher voltage, but we're not going to exceed the voltage of this. This is 450 volts. So we're not going to go higher than that. I'll be right back. Okay, 450 volts. I had to look this up. If I want to draw 50 mils, what resistance? 9,000. I don't have 9,000. I have 10,000. I got to be very careful. I push this up to 450. That's the max on this electrolytic here. So what I'm going to do is very, very carefully, I'll probably set it up to maybe 435, 440 or something like that, making very sure. As soon as I connect this resistor back up, after I have it set and I load this down, it's going to pull that voltage way, way down, and that current is not going to go up to 50 milliamps. I have yet to see anything above maybe 15 mils at the most. So this is probably a 25 mil max at any voltage, regardless of where the switch is. In order to get the low current of a few mils, I have to keep it on ×1. You would think that pushing this up would give you $250 mils, but that's apparently not the case, because there's nothing in this unit that can limit the current. I've covered everything. There's no other resistors in here that limit it. This is the bleeder resistor, as I said so many times before, 47K. This here is 150K, and it's not affected. It didn't make any difference bringing this back down to exactly 150K as designed by adding this other resistor, because this 150K was 172K. So we brought it right down, right on the money with this experimentation. We did that yesterday off camera. Okay, so what I'm going to do now is, off camera, I'm going to set this to 440 volts. I'll be right back. Close enough, 437. That's what we got coming out of here and what's across the 47 microfarad 450 volt electrolytic. We don't want to go over that on this. So we're in parallel with that, and the idea is to try to get more current out of it, but that's not going to happen. But this is probably what I would do. I'd put two of these in series with 470,000 ohm bleeder resistors to balance off the two electrolytics like I explained before. I'd probably put two of these in series under the chassis to go in parallel with the 12 microfarad 700 volt. So that way we can crank this up all the way. But just adding this didn't make no difference on the current at all. So now what we're going to do is to push this up to ×10. Now it's calls for a 9,000 ohm resistor. I don't have a 9, I have a 10. So in the ballpark, with this set to ×10, supposed to be 10 times the reading, so we should be getting a reading 50 mils there or a little less right here. But we're not going to get that, I can tell you right now, because when I connect this up, I'm going to put it on now, 385 volts. Okay, well, we're getting 4 mils. Don't forget this thing's on the side. This meter don't seem to be affected by being on the side, but this one is. So we can't really go by the voltage there because we're reading over 400 volts. But like I say, it's because the meter's on the side. The whole unit's on the side. We're getting 385 volts. We'll take the load off of that. And that is very hot. So we're getting the current out of it, apparently, but it pulls the voltage way down. Now we're back up to 437 volts because I took the 10,000 ohm resistor off. Like I say, It originally called for a 9,000 for the current that I wanted to get of 50 mils, 450 volts going in. Actually, it's less because I didn't want to damage that electrolytic, so I'm feeding in 437 volts. Yeah, 437. And I want to get 50 mils, and it's supposed to have 9,000. So we've got 10,000 across it. So it's not going to be exact, but it's close enough. All right, so, okay. But what you have to do with this power supply is whatever you're powering, when you set your voltage, which I like to put a voltmeter on the output. I don't rely on this. So what I like to do is to put a meter on it so I don't damage my equipment, like especially with the battery radios that require 68 volts. And then when I connect the radio up, I have to crank up, as I showed you in this video a little while ago, crank up the voltage a little higher as needed in order to get the 68 volts that go into the radio, because the radio's drawing about 12 mils or so. Well, that 12 mils really pulls this thing down. So, okay, now let me try doing the same thing and taking this electrolytic off. I want to see if the current is going to change. So what we've got now is 437 volts going in. The load is off. This is the resistor here. The load is not on. But we're going to briefly connect it back on. It dropped it down to 386 volts. About 40 mils, because it's on times 10. If I flip it down to times 1, it'll peg the needle. Okay. So let's take the load, let's take the 50 microfarad, 100, yeah, 47 microfarad off. Still 386. And it's still the same amount of current. Okay, let's take the load off. Let's turn it off. Okay, and the bleeder resistor, which is right here, is bleeding down the current. Let's put this on, yeah. See that? That's the bleeder resistor that's doing that. When you flip this power switch down, it puts on the bleeder resistor. If you just turn the power off on this by way of here, okay, and don't flip the switch off, you don't have your bleeder in circuit, then you can see the discharge of your capacitor, but it's a hazardous way to do it. So apparently adding another electrolytic to have more capacity would give you better filtering. And as far as the danger is concerned, it can kill you, whether you got 12 microfarads at 450 volts coming out of this, or whether you got 47 microfarads in parallel with 12. You do the math. I can't do it in my head. It's going to kill you either way. So, it's dangerous, you know. But I'm looking on eBay for some pilot lights. There's a seller that I might get the pilot lights. They have 2 of them for $12, free shipping. They're industrial type, LED red. I don't have any large vintage looking with a bezel on it red. 120 volt pilot lights. It's got to be 120 volts because that was the neon that was in here. Otherwise, I'd have to have a little transformer to run it if it was, or make a little DC power supply, reduce it down with a resistor and a diode. I don't want to do that. These are ready made. You just slip the leads, you strip these and stick these in the back. And it's seller is in Florida, and I'm tempted to buy it. This hole is 1/2 inch in diameter. I measured it. And it takes a 5/8 inch hole, so I'll probably have to use my step bit and drill that larger. I just wished I could get that Variac in here, but like I say, it's too tall. I tried thinking that maybe I can put the Variac up here, but it's not going to fit because the plate is too big. You got mounting screws here, so you can't do it. And the only way I could do it is to eliminate this, cut off 2 back mounting screws on here, and I'm not doing that, and remove the filament transformer. Now, I had a brain fart. I get those a lot. This is off. This is off. I had a brain fart. Yes, everybody gets a brain fart, but when you get older, you have more of them. Okay. Let me connect that back up. Keep it discharged here because we're off. You remember me saying why they used a filament transformer here to supply the the filament 5 volts for the 5U4? You remember me saying that? If you watch my video and listen to what I say? Who listens to what I say anyways? Okay, all kidding aside. What? Oh, you're serious out there? Oh, okay. Well, you're entitled to your opinion. Anyhow, when I was going to build my power supply, I was going to do it the same way as this. When you feed the primary of a power transformer that has a filament winding on it also, you're not only varying the high voltage that's coming out of your secondary, you're also varying the filament voltage from 0 to whatever it is. You can't do that. So, remember saying why they had a reason to do this? Maybe because of the breakdown voltage? Well, that's not the case. The reason is the filament transformer is getting its 110 volts, or 115 in my case, going in at a constant 115 volts in order to supply 5 volts to feed the 5U4. You can't use the winding, filament winding on the power transformer that's feeding the high voltage here because you're going to be varying the filament voltage and that just won't work. So what I was going to do, but I don't really think I will do it, convert this to solid state, 1N4007 diodes, remove the 5U4, so you no longer need the filament winding. Remove the filament transformer. By the way, the meter went perfectly right down properly. What was happening before, and I'll get back to the filament transformer in a minute, is this was binding in here. This one's never affected. I never had to touch this. This one here kept binding on me. And it got so bad that when I put it down, the meter was reading 1/4 up the scale and stayed there. I couldn't do nothing. I was adjusting this, and you can see the thing moving back and forth inside here. The little bar that has a little slot in it. But nothing was happening to this, just a very little movement. It was binding. So I cut the damn plastic off on the inside. I didn't want to do that. But all I got to do is remove this face, and I don't really want to hot glue it in. So I got to be careful. I like these meters. This is what I like, nice vintage equipment. But anyways, okay, let's get back to the filament transformer. If I was to eliminate the 5U4, put diodes in it, I wouldn't need to worry about a filament, okay? So you wouldn't have to worry about using the filament winding on this, which you're not using anyways. This is only used for the filament of the 5U4. Remove that and mount the variac between the meters. The problem is the variac is 3 inches from here to here, and that's exactly the spacing I got here. But if you look down there, see where my finger is? That's one of the meter nuts. I couldn't get it out. I couldn't get it back on. I could not get it back on, so I had to leave it out. I took this meter out yesterday, and I thought there was a problem with the meters. Now, I have very, very bad luck with meters. So I'm so glad I didn't ruin this. So it was binding on that little plastic thing, because no matter where I put it, lined it up, it just screwed up the meter. So I said, the hell with it, turn it off. If I have to, I'll take the top off, take it off, and adjust it manually, and that's what I did. But anyways, if I eliminate this, the distance, I think, between here and the back of the transformer might fit the variac. I would have to take very careful measurements. But I would have to cut off these 2 screws, and in order to do that, I would have to pull both meters out and cut them, because I can't do it here. Which leaves the bottom corners loose on these meters, and I don't want to do that. And it's all because I want to get the variac right here. Actually, theoretically, get the variac right where the Bushler Instruments logo is. But I think I'll just live with the damn variac on the side of the cabinet and make myself more work. So we're going to get a pilot light. There is another one in China that has them, but they say it requires a 16 millimeter hole. I don't know. That I have no idea. It's probably close. I don't know. But we don't want to get a pilot light that's too small. The ones I've got, like I put in my instruments here, like on my ICO LEDs, well, there's I think there's 6.3 volts, and you just come off the filament winding of the tube. But those are too small. There is my box of power resistors. Almost none of them are marked. I did mark them when I got them, but it's all rubbed off. 364 volts. 400. Well, let's make a test here. I'll do that off camera. I want to see if this meter has high voltage going on it from here. It won't be to the chassis. The chassis is floating, as I said. If I take my voltmeter and go from one of these pins to the common negative post over here, I'm going to do that off camera and I'll give you a report on that. Well, yes. We're getting 370 volts. We're reading, well, it varies. My line voltage varies. That's about 400. Okay. Now, a lot of you guys might say, well, you're taking a digital meter which is high impedance, which I know, versus an analog meter, they're never going to jive. But this meter is definitely in series with the high voltage. It's across the high voltage, which means it's got to have a meter inside, a resistor inside. I'm going to turn this off and put the lead on the other side. It should be 0. There's probably a, I don't know, 100 meg resistor inside of this. I don't know. Now I'm on the negative post here, because I marked red positive because it's embossed in the plastic positive, but I like to be able to read it. So I got it on the other post now, and we're going to flip this up. And we're still reading. And my guess is correct. No reading. Okay, so what we've got here is actually just like I thought. We got a voltmeter that goes across the output, across here, to measure the high voltage. A current meter is in series with the voltage. A voltmeter is in parallel across it. Okay? That we fully understand. With me, I experiment. So what if we try all my resistors are low wattage on high ohms type. 10,000 is too low of a resistance. All I want to do is get the meter to read lower. It's reading higher than what the digital meter is showing coming out of here. If I can't do it, we'll simply just remember that this meter is reading wrong, and I always put a digital meter on the output anyways. I even do it on this because it's, it's hard to see the analog meter and you want a precise voltage coming out. That's the way to do it. Other way I might be able to do it is to put a resistor in series with that. I don't know what the internal the shunt resistor is for this. I don't like putting an ohm meter across a deossable movement meter, which is what these are, because they're very, very low voltage and very, very low current meters, and you can be damaged very easily. Amp meters usually have a big, heavy, low ohmic resistor across them, but not voltmeters. So there's no way, and I'm not going to open this thing up because I've ruined more meters trying to do that. We can try a resistor in series with it. Because it's in series, it should be all right. But I'm very limited in resistors. So let's say I put a 10,000 ohm resistor. Everything's experimental with me. Lift one of the legs on the back of this meter, put a 10,000 ohm resistor in series with the meter, which is not going to load down the power supply. It should get this down a little bit and should not affect the voltage coming out of here. Again, I'll be back. Okay, what I did here is I disconnected the negative lead off the meter. It don't really matter because I'm going in series with it. I have a 10,000 ohm resistor, 10 watt, in series with the voltmeter. Oh. And 10,000 doesn't do too much. 365 volts. Do 400 volts. You'd think 10,000 ohms would reduce that a little bit. Again, everything's experimental. I cannot do formulas and math and Ohm's law. I just can't do it. Old Nate Carver there, he tried to drill that into me years ago. I still to this day can't do it. Everything's experimental. All right, so let's shut it off. Let's feel the resistor. Ice cold. So I got to find something higher than that. And the only thing higher I got is low wattage resistors. That's all I got, but I'm putting it in series with the meter. But I have no idea. It's got a resistor across it. The question is, what wattage is it in there? It can't be that much because this whole case was plastic and it would burn up with a high wattage resistor in there. 1 meg. We'll sacrifice this, but we're gonna turn it on and very quickly watch this thing go up in smoke. It's not going up in smoke. 367 volts. Oh, 200. Okay. All right, let's turn it off. Experimentation, folks, experimentation. All right, let's try a 470,000. Let's go half of this. All right. Again, half watt, quarter watt, but that's all I've got. So, let's put that on. Yeah, we're doing better, but 367 volts. Nope, we got to go lower. Experimentation. You guys out there with your math knowledge, wizards out there, are probably laughing at me. Probably saying, use this kind of resistor, use that. That's why I'm a tinkerer. I get the job done, it just takes me longer to do it. But hey, I got nothing better to do. Hang on, we're going to go change the resistor to, let's see, we'll guess at it. Let's go around roughly maybe 300,000 or somewhere 330. We'll try that. I'll be right back. Well, I couldn't find a 330. I've got them, but they're doing the loose packs. Okay. A little over 300. 366. So, well, let's go to 220K. Right there. You know what I would like to do is to be able to get an exact voltage on that. And let me turn the meter. Let me turn the voltage down to 300, but we'll make sure it's 300 on this meter. I'll be right back. Okay, we got it 300 there, and we're under 300 there. So what do we got to do here? To get that higher, we have got to drop the resistor down below 220,000 ohms. Am I correct? We'll soon find out. We'll go find something a little lower than 220K. 180K. All right. Not quite. I think the next one down I've got is 100K, but let's find out. We got to go lower. 100K. What do you think, folks? Almost 300. We dropped a little bit because of the line voltage does vary a little. 305, that's close enough. I can't really complain about that. It looks like 100K is the baby. All right, now we want to check for linearity here. So let's go to 200 volts. I can't complain about that. 207, I'm not going to nitpick because I don't have anything that would be different. I'm not going to be plotting around a whole bunch of resistors. So what I have to do is to make up something that will go in series. I could just cut one of the leads and insert the resistor that way, which I'll probably do. All right, so we're 100 now. Let's drop it down to, 200 rather. 100. 102. Can't beat that with a stick. 50. 49.39. You can't beat that. Let's go up to 300 again. $307, okay. Let's go to 400. There's 400. 398. Okay, we're doing good. Now let's go to 500. Let's go to 450 first. There's 450. 448. That's no complaints there. 500. 500. You can't beat that, man. Perfect. Ice cold. Okay. So my sometimes I get a little mixed up with things. It's experimental. So I burned up a resistor trying to go in parallel with the meter. But I didn't use my head, except for a hat rack. But I admit my mistakes. Nobody's perfect, and I sure am far from that. So we're going to put that in series. And we'll do that off camera. We'll make up a little heat shrink thing. We'll clip it on the... We'll cut this off and put it in here. So, 100,000 ohms is what did it. So obviously the resistor in here went down in value. So we had to add 100,000 more in series. So we're doing good. If I can get this to give more current, I think we got it made. All right, so right at the moment, I'm going to take care of that, and I'll be back on, show you how I did it. Okay, it's just held it in place here. We'll just slide this tube heat shrink down over it. Probably have to use two hands. I'm not one of these one-handed guys. Hang on a minute. Okay, we'll just put the heat gun on that, and we're ready to connect it up here. I think it came out pretty good, if I do say so myself. I'll be right back. See me in there or not? It's the best I can do with my half-ass workshop here. Okay. All right. So, now, we can put that back on. That's not bad, huh? Now we find a proper wrench, which I think is here. You got to be very careful when you tighten these up, because if the inner nut turns, you've ruined your meter. So we don't tighten them very tight at all. Looking good. Now we can put the 5U4 back in. It works better that way, huh? Okay, now we're all back together here. So we're going to go and check it out one last time, and that should be the end of this video for today. Hang on a minute. Okay, with one final test here, and we'll end the video. We got it set on 50 volts right now. It's going to vary because of my line voltage, so because the variac is on the primary of this power transformer. It's 100 volts. Mm-hmm. 250. 200 rather, I'm sorry. 200. 250. 300. $250 as close as I can read it. $350 rather, $350. $350. $400. $450. That's it on $450. That marking that's on the plastic is really making it very hard to read that needle. But as close as I can see, I think I'm on 500. Okay, so we'll turn this down and we'll shut this off. And that concludes the video. I just got to go to eBay and look at some more Pilot lights.